Hey guys, Villani here, you okay? So in today's video, I'm gonna show you how to use 3 different types of mapping that don't depend on the mapping done in your object's UVs. The first one will be screen mapping. Screen mapping does the mapping depending on where your object is on the screen. So as you can see, it's like my texture is on the screen, projected in my objects. The second one will be world mapping. World mapping maps your objects according to the position they are in the world and from a plane. So in this case, my plane is the front one, and as you can see, if I move my objects, it's like the texture is in the world. It has some problems. It causes stretching from the directions where the planing are coming from, and to solve that, we can use tri-planar projection. Tri-planar projection projects a texture or several textures from all the sides in your object, and you can smoothly blend among them to make it look like the object is mapped to use the texture. As always, if you want to learn something specific from the tutorial, I leave the timings of the topics on the video description. Now let's begin! First, let's talk about the screen mapping material. So first create a material here, right click, choose material, m_, screen mapping. Double click to edit the material. I'll dock it here. Alright, so to map your texture to the screen, you need to know where the pixel currently being rendered in the material is in the screen. For that, you have a node called screen position. So if I just plug the screen position into the emissive color of the material, or base color, anyone that shows colors, and apply on my objects, you'll see that my coordinate colors are mapped to the screen. So if I move my objects to the left upper corner, they become darker, because here is the 0, 0 of the coordinates. If I go down all the way to the right bottom, it's yellow, because it's red from the horizontal channel, plus green from the vertical channel. So here is 1, 1 in my coordinates. And that's it. Now I just need to plug this coordinate into a texture. So I'll create a texture node here, hold T and click. Plug this in its UVs, choose a texture. If you enable the show engine content here, there's a texture called the full texture. The full texture. It's part of the engine, so every project has this texture. I'll plug this on base color, unplug emissive color. And now even here on the node, you can see my texture is mapped to the screen. As you can see here. So my texture is mapped to this viewport here. If I apply, I have it mapped for the screen. So it doesn't matter the angle I look at my objects. It will always be mapped to the screen. Now if you want to move this texture, scale it, you can. To tile textures, you just multiply its coordinates. So multiply. I'll create 2 nodes here for tiling. U tile for the horizontal, and V tile for vertical. I'll leave the default as 1. Append these so we create a float2 vector. So X and Y. And multiply my coordinates by these numbers. Now to offset my texture, I need to add to its coordinates. So add I'll copy these nodes and I'll call them U offset and V offset. And the default values I'll leave at 0. So by default we have no offset. I should have copied the append node to... Okay. So if I compile this, I'll create an instance so I can change these parameters in real time. Create material instance, mi underscore screen mapping. I'll apply it to my objects. I'll select them all. Find the material here and change it to mi underscore screen mapping. Alright, so now if I edit my parameters, I can move the texture, scale it, so U tile and V tile is the scale. If I tile by greater values, my texture will repeat in the screen. So vertical and horizontal. This texture is good for testing because it's a tiling texture. It means it can be repeated without seams. So as you can see, it's smaller now. And I can also move my texture. U offset, V offset. So I can move it horizontally and vertically. Alright, that's it for screen mapping. Now let's do world position mapping. I'll create another material. M underscore world mapping. Double click. So before, for each pixel, you had to know its position on screen. Now you need to know its position in the world. The position on screen was already a 2D coordinate. Now for the world, as it's a 3D world, we have a 3D coordinate. In order to use a 2D texture, you have to filter only 2 coordinates and choose if you want to map it to X and Y or X and Z, Y and Z. So first, I need to know the position of my vertex or the position of my pixel. So to know that, search for world position. World position. Absolute world position. So now, for each pixel, I know its position in the world. Now I need to choose 2 coordinates for projection. I'll drag a line from here and type component mask, this node. So now I can choose if I want R, G, G, B, RB, etc. These are relative to X, Y, and Z. If someday you forget, just look at the colors in the gizmos here. So X is red, Y is green, Z is blue. Let's take a look here to choose a position for mapping. If I want to see my texture from top, I want to map its coordinates relative to Y and X. The both axes I can see from the side, not the one pointing at me. If I wanted to see my texture from the front or the back, I'd have to map it to X and Z. And from the side, I'd have to map it with Z and Y. So I'll choose Z and Y. So we can look it from here and from the other side and see the mapping. So Y and Z. I'll create a texture. Hold T and click. I'll use the same texture. The full texture. Okay. Plug it into my base color. Now for this mapping, you have to know which of your coordinates is the horizontal coordinate and which of them is the vertical one. So let me go back here. In this case, it's very easy. My horizontal is Y and my vertical is Z. If I was looking from the top, I could consider X as horizontal, or if I want to be right from here, Y would be my horizontal. So just take a look first and decide which one you want to be the horizontal and the vertical. In this case, Y is horizontal, vertical is Z. As this node gives me the components in the order that they appear here, it's already in the correct order for me. So G and B. If it was not, I could create separate nodes for G and for B. And then append the vector in the order that I want. But in this case, it's already in the right order. Well, now I have my coordinates. But as you can see, you can distinguish the texture here. It's repeating too much. That's because Unreal gives you the position in centimeters. So for each centimeter, your texture is already going from 0 to 1. That's the space for a full texture. You have to divide this value by some other value to make the texture bigger. It's like tiling. So you can either multiply or divide this value by some other value to make it tile less. In this case, I'll divide because, for example, if I want to map the texture, a full texture for each meter in the world, each meter is 100 centimeters. So I can take this coordinate, divide. I'll create a texture size value here. I'll leave the texture square. No, I'll leave the texture in a free ratio. So it will be texture width and texture height. So my texture width will be 100. And same for the height. These will be the defaults. So for each meter, my texture will tile once. So I append the vector in order to multiply it by another float tool, or divide in this case, and plug it here. So now for each meter, my texture tiles once. Let's compile this, and I'll show you the effect. First, I'm going to create a material instance here. Call it mi_world mapping. Apply it to my materials. mi_world mapping. Alright, now you can see a problem. As my texture is being projected from this plane or this plane, from this side, it's stretched because imagine like there's a pool of paint with this texture and my objects passed through this pool like this. So that's what projection basically is. You choose a plane and project the texture from this plane. And as my texture is mapped through world position, if I move my objects, the texture, it's like the texture is in the world and my objects are taking its coordinates from there. So it doesn't matter where they are, the texture is always in the same place. You can also do tiling and offset with this texture. Since we'll do tiling and offset very frequently, I'll create a function for that. Let me go to the screen mapping we did. No, not the instance. The material, where is it? m_screen mapping. I'll copy these. Ctrl C. I'll create a function. Right click. Materials and textures. Material function. mf_ tiling offset. Double click to edit. Ctrl V. So I'll output the result coordinate and create an input. It will be a float tool and my original coordinate. I'll call it UV. And for my default value, I'll hold U and click. My default value will be the default UV mapping for the material. I have to activate this, use preview value as default. So now I'm getting coordinates and changing it with tiling and offset. In every material I use this function, I'll have these parameters to change in the material instance. I'll apply. Let's go back to my world mapping. I'll hold F and click. As my function was selected in the component in the content browser, it was already set for me. But if it wasn't, I could just select my node and select my function here. So I want to take these coordinates and do tiling and offset. I'll compile. Go back here, wait for it to compile. Right? Now, if I get my instance and change its parameters, for the texture height and texture width, this is practically the same as the tiling, but it's values that are much easier to think of. For example, I want my texture to occupy 200 centimeters by 200 centimeters, 2 meters. So it's easier to think than to go here and I want to get it to 1 is 1 centimeter, so to have 1 meter I have to divide by 100, so it would be 0.01, and it's easier to think this way. So you can do both ways. Now, I have my texture occupying 2 meters. I can screw this up with tiling. So now it's 2 meters repeating twice. So actually it has a width of 1 meter. I can do the same with V-tiling. I can change the offset so I can move my texture. Same thing as with the screen mapping. If I wanted to see my texture from the front, you just have to change the coordinates. So I have X for horizontal and Z for vertical. So back to my material. I'll change my horizontal coordinate to red or X. Z is already my other coordinate. Apply. So now my texture is seen from this angle. Or this one. And that's how you do world mapping. Now, what if we wanted to have our texture to be correct from here, but also from here and from here, without this stretching effect?